Hey everyone, and welcome to this session called Event API Management, Secure and Mediate Events for Any Client Protocol. My name is Linus Hakansson, and I'm a VP of Product here at Gravitee. So in this session, we're going to be talking to a taxi example, actually, of both synchronous and asynchronous kind of architectural and processes. We're going to address some of the challenges with managing such asynchronous events. And then we will have a look at how modern API management solutions help address some of those challenges. We'll then go into a demonstration where we'll see how we can use async APIs and specifically WebSockets on top of that use case with the taxi booking, and also how we can use OpenAPI and REST as another option of pushing messages into our broker. We'll look at how we can do protocol mediation with solutions like Gravitee and Solace, and how specifically we can make sure that every event and message in our broker is secure by nature using OAuth 2. So let's go through an example of ordering a taxi in a couple of different ways. So our use case is pretty simple. We have Mario here on the left, whose intent is to order a cab using his mobile phone application. So he wants to order a cab, and he would expect that the taxi company or some type of taxi service would receive this request, acknowledge it, and then potentially let him know that and who and how they are arriving to pick him up. Now, in a traditional synchronous kind of architecture and message flow, what typically potentially could happen here is, as part of Mario's intent here in the app that he wants to book a taxi, there's a post call over the HTTP protocol being made to that taxi server effectively, asking for a booking. Now, in a synchronous way, typically what happens is the taxi company says, yeah, sure, let's get that sorted, and they will make a response immediately, potentially giving a location of where he could find more information of when the car is arriving, really. So then what happens is Mario's mobile app would need to understand and get information of what is the status of the car. Have you received any information? Has any driver accepted this booking? So typically what happens in the synchronous model is that the client makes a series of GET requests on that location that was received in the post call, asking for the status of the booking. So we're making GET calls. If we're not getting a response or nothing is there yet, we'll have to wait, and we'll have to maybe replay this request a few times until we actually do have a driver here. In this case, it's Robert De Niro, who's going to be driving us to Westminster Abbey. Now, naturally, there's a few challenges with such a solution. Obviously, there's a waste of resources in terms of this polling being made. It's definitely not real time because the client needs to make these requests in the mobile app, and it's not going to be more real time than the frequency of those requests being made. It's also going to be very difficult to enforce any quality of service policies, such as ensuring the number of messages per second, or ensuring the response time, or ensuring that a message is only sent once, and so forth. So how have we solved this problem of real-time messaging? And most of you will know, because that's part of the EDA Summit, is event-driven architecture and event brokers. So one way to look at this differently is to decouple the publishers and the consumers, and also having a broker in place to kind of broker between these messages. So in our case, Mario's mobile app will send messages to a broker. That might be Solace, that might be Kafka, MQTT, RabbitMQ, something else. And then several consumers, so that might be different taxis, or actually maybe different taxi companies, would subscribe to different topics and queues, maybe for different countries or different regions or different kind of sub-companies under that, for messages of bookings of taxis. So how could that look in the case of our mobile application here for the taxi booking? So we will place a message broker here in between the client and the server, or the consumers or the subscribers in this case. So after Mario's intent to book a taxi, it's basically published from the mobile app to the message broker, and then we have some logic on the broker side that might say, based on this message, we have these different queues or topics, and these different subscribers are listening for those messages. And in this particular case, one taxi company or one maybe even car or device might be consuming that and saying, okay, I'm able to take that request, and I'm going to be publishing an event as well on the broker that then, of course, the application on the client side is consuming. So we know in the app which driver we have and the destination, again, that we're looking to go to. And this obviously gives us the real-time capability, and also, of course, decouples the mobile app to the actual backend services. So I'm sure most of you are familiar with these kind of architectures. And again, indeed, that's kind of the theme of this particular summit. Now, what are some challenges with managing those event-driven architecture and some of those events when it comes, of course, to the consumers and producers of those events? So one challenge, of course, is that you have a message broker. Typically, your clients, whether it's a consumer or producer, will need to know and respect that complexity and architecture and protocol that message broker might be using. So what happens down the line if you change message broker? Of course, you might have to update the logic on your consumer and producer sides. What happens if you have other devices that maybe you have a legacy kind of a protocol or a device that are not able to talk the protocol of your message broker? How do you address this? And how do you address the life cycle of your producers and consumers? How do you make sure that they are secure and connected? And specifically, as someone creating a mobile application, you need to understand the underlying protocol and the underlying complexity of the broker. And someone exposing that broker and providing that service need to, of course, understand and be confident in how do you expose the broker securely to different parties, whether those parties are applications, mobile applications, or maybe other types of protocols and sources sitting maybe outside of networks and outside of kind of different boundaries. And again, what if the broker changes? How do you manage that change? And how do you make sure that your consumers and producers are able to keep up with kind of the pace of innovation in terms of those different protocols? And again, what if some of your producers and subscribers cannot talk those asynchronous protocol? It might be because of security concerns. Maybe they have certain security standards that they apply to, or maybe they just sit on outside a particular network and just do not have the ability to access a native broker potentially. Or just, again, because of that client maybe not being able to install a Kafka client or an MQTT client in the particular device or application. Or it might just be due to the data flow style or the nature of that kind of messaging. Maybe, for example, you have a client that actually only wants to make one call per day to receive a bulk information for whatever reason, maybe down to cost or performance or just availability. Now, with the modern kind of world of new protocols and a lot of different kind of use cases around consuming in an event-driven architecture world, you of course have different technologies like Kafka and MQTT for these publish and subscribe use cases. You have WebSockets for maybe using web applications or mobile applications that stream over the HTTP protocol. You might have webhooks and server-sent events where someone registers their intent to be interested in a particular topic or subscription and expect an HTTP post call to their particular URL whenever an event has been sent. You also have languages like GraphQL that support subscriptions over WebSockets that you might want to have in terms of your backlog of consumers. And again, what about all those clients that can only talk synchronously, but still wants to be part of this ecosystem, and in our case, the taxi booking world? So to summarize that, how can we, and also add a few other things that would be good to have in this world, how can we make those events, topics, and queues discoverable for our consumers and our applications? How can we enforce governance and monitoring on top of them? For example, making sure that the payloads are adhering to a particular standard, or that we have the right information in the payloads. And how can we ensure that we have the right monitoring in place so that we know who is consuming and how they are consuming? How can we secure access across different protocols potentially and across different architectural styles? How can we, if applicable, transform and translate messages? Maybe some consumers or producers are sending data in XML and some are sending in JSON, and we want to make sure that the data is in the right format, and potentially for some clients we might need to apply some transformation on the data itself. And again, how can we minimize the impact of a potential change on the broker side or on the client side? And with all of those different protocols and messaging styles that we've covered, how can we make sure that it accommodates a lot of different use cases and different consumers and producers? Now, some of those use cases might address challenges that some of you might be familiar with. API management providers, of course, have been in the business for a long time to address kind of things like monitoring, lifecycle management, design documentation, but obviously very focused on the REST and SOAPs of the world and the more synchronous type of architectures. Now, we believe that a modern API management solution should help cater for event API management and the addressing some of those challenges that we have just found out with our taxi example. So what is API management for those not aware? API management is a set of processes and tools that enable the design, development, deployment, and maintenance of APIs. So most of the API management vendors and platforms out there have some kind of security and protection capability to either rate limit or provide API keys, basic authentication, or some type of security on top of your backend services. They typically also have some kind of translation and transformation capability to actually change and mediate or transform the data as it moves through their gateway. They might also have capabilities to design and expose and document different APIs on developer portals, for example, and providing analytics and monitoring capabilities to understand who is using what and do I have any challenges or error codes that I need to be aware of. And of course, managing a community and an external or internal pool of people wanting to produce and consume those APIs. And that can be everything from accepting requests, terminating API keys, or other types of lifecycle management procedures. Now, in the case of our taxi booking example, if that was an API managed by an API management platform, typically you would have your developers, your app developers. So in our case, that might be the user that developed the application that Mario is using, that would define or rather discover the APIs that are available maybe in a developer portal, maybe trying them out immediately in the developer portal, asking for a subscription in the developer portal, and then seeing maybe some analytics on how their applications are using different APIs. An API owner using API management would typically design and document the APIs and make them available in something like a developer portal for different application developers. They would also manage the access, the security, any type of traffic shaping on those APIs, and also deploy them to different gateways or brokers or whatever type of infrastructure it might use. And of course, they will also have access to monitoring and analytics information to understand not only how their APIs are being used generally, but how different applications are using their APIs. So in our case here on the bottom, we would have a mobile application making requests, maybe then secured and authenticated by an API gateway before it's routed to a message broker. And technically how that might work and what kind of benefits we will have from that is something that I'm going to be going through in the demonstration later on. Now, what we expect from those modern API management platforms to support also event-driven architectures and async API, for example, is of course the ability to design not only traditional open API specifications, but also async API specifications. Now, obviously, async API is typically using the JSON schema model for describing the payload, very much as API 3.1. So modern solutions would probably have a way to structure your JSON schemas, your different models to represent the data, and make that available for designing open API and async API specifications. They would also have the ability in a developer portal to not only manage and expose open API specifications, but also indeed async API specifications. Now, obviously, the nature of event-driven calls and messages are not the same as traditional synchronous ones. So you might be looking at things like number of messages or the throughput of different topics and subscriptions rather than traditional API call analytics. And again, you would need some kind of lifecycle management to also manage how people, subscribers, and producers are working on your topics or queues. Now, one thing that we believe is quite important for offerings and solutions to help bridge this gap between both asynchronous and synchronous kind of clients and different messaging kind of boundaries is, of course, to support both synchronous messagings like REST and SOAP and some level of GraphQL, but also, of course, supporting asynchronous types like Kafka, MQTT, WebSockets, webhooks, etc. So if you take an example of what one of those mediations could look like, and again, this might be a use case for us with our taxi booking application, because we might have an event broker, maybe it's Solus, maybe it's something else, but on the consumer side, we want to have a mobile application, maybe using WebSockets. Now, how that technically works is that the mobile application over WebSocket would connect to the gateway using the HTTP protocol and ask for an upgrade of the WebSocket protocol. So that will then be accepted, and they would actually upgrade and switch that protocol. And then it will be a full duplex communication between the mobile app and the gateway. Now, while that is happening, the gateway would also set up the connection with the backend protocol, whether that is, again, Kafka, MQTT, Solus, or something completely different, maybe a REST API, to make sure that there is also a full TCP-based duplex between the gateway and that backend service. That means that now you actually have this kind of bidirectional real-time streaming of data between a mobile app and a backend event broker like Solus. Of course, you would also have the capability to close that connection once you're finished with your WebSocket. Now, another quick example is Webhooks. So Webhooks is working slightly differently. You would, again, still have a broker on the back end to consume and subscribe messages. But in this case, you might have a client, maybe it's, again, our taxi mobile app that says, I want to get a message on this particular webhook URL whenever there's an update on a particular topic of subscription. So the mobile app is registering its intent to subscribe on a particular topic or subscription to the API gateway, telling them where my webhook is whenever there's an update. That is then obviously then registered and forwarded to the broker, making sure that whenever there's a new message or update, in our case for the taxi's driver update, that message is then consumed by the gateway and sent to that mobile app's URL, the callback URL that was registered during the subscription phase. So what is Gravitee, and how can Gravitee help with some of these use cases? So Gravitee is an API and access management platform. We provide a freemium version, Cockpit, and API Designer, which we will have a look at in a few moments, as well as an open source edition. So our open source edition is mainly focused on API management and access management. So as we've covered, API management basically includes everything from managing your APIs, providing security on top of the APIs, making sure that you have traffic shaping and that you can expose them on a developer portal and manage that lifecycle with your consumers. It also, of course, includes a gateway to actually physically protect those backend services and mediate potentially between protocols. The access management capability allows you to put OAuth 2 and SAML on top of those APIs to make sure that they are secured, and you have capabilities like fingerprint or Face ID to actually authenticate and get the tokens right. Now, in this demonstration, I'm going to go through an architecture. We're going to come to that in the next session. Everything that I will be demonstrating is with the Gravitee open source or freemium version that anyone can have a try with. Specifically, what we will do with our taxi case here is that we will try to see if we have this set up using an event-driven architecture. In our case, it's going to be set up with Solus. The taxi drivers might maybe use Kafka or other protocols to communicate with Solus. The Gravitee gateway might use different ways. In this case, it's set up with MQTT towards Solus. But interestingly here, we are supporting multiple different types of applications and mediating protocols. So in our case, our mobile app that is making the bookings and in real time understanding what is the status of my booking is going to be communicating over WebSockets. So the gateway is basically mediating between WebSockets and the backend service here, which is on Solus. We're also going to see how we can support clients like maybe a legacy application that cannot talk either WebSocket or any other kind of modern asynchronous protocol, how they can use REST to actually push data, maybe make a booking over the REST protocol using an HTTP call that is then mediated and transformed back into Solus. And all this we will be securing with OAuth 2. So I'm now going to switch over screen here to my demonstration and talk you through that. So here in the API designer of the Gravitee cockpit, I already have a design here called taxi booking. So let's just go have a look and see how I have created this one. So I have an entry point here for the booking API. Each booking has an ID, a driver name. I can have a list of multiple destinations depending on how many destinations actually the booking is applying for. Maybe it's multiple destinations, and I can then set the order of each of those potentially. The customer name, in this case Mario, and then whether or not the trip has been completed or not. And for each of these, I can just simply go ahead here and refine, what type of objects they are, what visibility they have in the API, and some example data and descriptions of the various fields. It's very easy for me to add a new field. If I wanted to have another one to explain and describe destinations, I could just add another one here and say, maybe a destination also holds a country, for example. But for now, let's kind of stick with what we have here. What I've then done is I've gone in here to the push capability. So this gives me a chance to review what my API looks like. And again, in this particular instance, it is an async API specification, or sorry, an open API specification that I'm generating. We're going to have a look at async as well. So I can see here, based on how I created API, I can see here, for example, what would be the response if I make a GET request in terms of the ID and driver name, all based on that example data that I made into the design as part of this design part. What I've also done 2 hours ago is I've pushed this particular API into the Gravitee gateway and the management component. So it's already in a developer portal where people can go and subscribe to it. Now let's go have a look and see what else I have done with this particular taxi booking API. So coming here into my list of APIs here, we can see I have a list, an API here, called taxi bookings, which is a asynchronous API to manage taxi booking. Actually, I'm also gonna support an asynchronous method of pushing and listening to new bookings. So it's not entirely true, this particular description here. Now, everything I define here is basically settings that determine how this API will be reflected on a developer portal. So what I actually have here in this case, I have my open API specification, but I also have an async API specification. I can also have a look at how people can consume this API. So in my particular case, what I wanted to do is I only wanted people to consume over the REST protocol and over WebSocket. And regardless of what you use, I want only consumers to be able to authenticate their API using OAuth 2. So I've created a plan here, which is basically what defines the contract between an API producer and an API consumer. In order to define what backend, whether that is a REST API or whether that is a broker or maybe a Kafka stream, whatever it is, I have to go into proxy here and go into backend endpoints. Now, what I have here in this particular case is actually my Solus broker. So I have my username and password here for my Solus client, as well as the queue, which I want to pass messages to after the Gravitee gateway has authenticated and applied any kind of policies or traffic shaping on this request. So in this part here, I can define what should happen on the gateway side when the request either hits the gateway or gets responded back to the consumer after it has retrieved data from the backend. So what I'm saying here, that if the user on the REST protocol makes a booking using the post request, I'm going to apply rate limiting. So Gravitee supports more than 50 of these policies to allow you to do kind of different authentication, security policies, as well as traffic shaping and other logic to your APIs. In this case, I'm setting a rate limit to say that you're only allowed to do 3 requests per minute for this particular API. And if that passes, I'm going to change the content, the payload of the data before it reaches the backend, in this case, Solus event broker. So here I'm using some simple expressions to say that I'm going to take the original JSON body and I'm going to change that to a simple string here that says new booking by and then the name of that particular customer. And this is because maybe that's how I want the data to be represented on my backend, but I want my front-end user, my clients, to use JSON in this particular case, right? So we can very easily transform and shape how the traffic moves between the client and the server.
I can, of course, also see analytics. So I've used this API previously for a couple of minutes, and I can see what applications are using it. I can see potentially what paths they're using, the response times, and all that sort of data. Now, I'm going to take on the role as an API consumer. So going in here to the portal, and this is something that can, of course, be completely customized and bespoke and themed based on what your company provides. But here I have a category here for taxi bookings, and this is my taxi bookings API that we have just seen from an API owner perspective. So as an API consumer, I will be able to go into the documentation here, and I can, of course, either have a look at the Open API specification that we, obviously very similar to, or identical, I should say, to what we did in the API designer. I can also go into the Async API specification here, which is in this particular case allowing WebSocket communication with this particular API. So we support, again, REST and WebSocket in this particular API. So I have two operations. I can publish message to the booked taxi queue, and I can subscribe to it. And we can view the structure here of the different messages. So the payload itself is identical to what we have for the Open API specification. So what I've done here in advanced is I've actually registered an application to this API. So an application is basically, in our case with the taxi booking, it's what represents that mobile app that is using the APIs, that has access to the APIs. So in this case, for my application that I have created, I actually have two subscriptions. I subscribe to another kind of football score API, and in this case also to the taxi bookings API using this OAuth 2 security type. So as a application owner, I know I have access to my client ID and client secret. I actually have hard-coded in a Postman callback URL here because that's effectively what we will be using for this demonstration. So really the next step here is to try this out. So again, what I want to do is I want to try two different things. I want to see how I can, as someone using a REST protocol, send messages to Solace with transformations applied to those messages. And secondly, I'm also going to connect a WebSocket connection, again, securely over OAuth 2, to be able to stream those messages back and forth between Gravitee and Solace. Okay, so first of all, I need to get a token. So I've entered here my client ID and client secret based on what my application had here in the developer portal. So I'm going to say get new access token. It should basically prompt a Gravitee access management screen here, which of course can be customized, and it depends, of course, on what type of authentication I have enabled here. So I'm just going to sign in this case with basic authentication. I could set up things like fingerprint and Face ID. But for now, I'm going to skip that and just use that token. So I'm going to use that in Postman. I'm going to open up my other Postman client kind of side by side here. There we go. In fact, let me come in here under headers and just steal this entirely. Okay, so now we are having the same token for both a WebSocket and a REST connection. So actually, let's go and connect using WebSockets first. So I'm making a connection right here to the same gateway for the taxi API. And now I'm going to send this payload here on the body. So I'm going to say that the customer name is actually Mario. It's not completed yet. And these are the destinations that I want to be using. So I'm going to make a call here. We can see it now says new booking by Mario, right? So we did a transformation of the data on the gateway side before it reached, in this particular case, Solace. And then maybe Solace directed to Kafka and other clients. But we're also able here using the WebSocket connection to consume and produce those messages. So I'm sending another one here. If I try a few more, most likely going to say here, actually, we're not getting more messages because we've already reached that limit in terms of the rate limiting.
So that's a demonstration. So to wrap up, I want to just summarize what we've been covering. So we've covered different ways of looking at a taxi booking example for different subscriptions and consumptions, both with polling, with a publish subscribe model, with webhooks, and with WebSockets. We've aired some of the challenges that arise with managing events and how a next generation API management platform could and should be able to support also those kind of event challenges. We've gone into some level of Gravitee demonstration, looking at how we can visually design APIs, how we can make both async and open API designs available in a portal for people to consume and discover, how we can manage the life cycle and subscriptions of those, And now we can apply OAuth 2 on top of any protocol like WebSockets and REST to allow those other types of clients to communicate and work in this broker architecture. We looked at how we can use some traffic shaping like rate limiting and payload transformation before it's being sent over to Solus, and also how we mediated between different protocols, both REST and WebSockets, again, on top of the Solus broker. Now, what's next? I'm obviously available here still in the chat if there's any final questions. My email is below, so don't hesitate to send out an email to ask any questions or feedback on this presentation. Again, Gravitee is a proud open source company, and you can check out our repository, clone and fork or code and contribute and download and just have a go. We also have a community.gravitee.io, where people are sharing their Gravitee stories, meeting other users, asking different questions and helping out with answers, and as well, obviously discussing wider kind of architectural concepts and use cases. So that's all. Thanks so much for taking the time to view my talk, and I look forward to chatting with you later. Thank you.